Good evening, Miss Jetifa. Here I want to present my intelligent search engine final exam. My name is Viona. And for number one, um, tokenization is like cutting a sentence into smaller pieces so that a computer can understand it better. It breaks down text into meaningful chunks like words or sentences, which can then be used for different tasks. And in the code example, we see there are three types of tokenization. One that separates the text into sentence, one that divide into words, and other that treats the punctuation marks as separate units. And this tokenization method helps us to analyze and process text in a more organized way. And then for stemming, it is a process that simplifies words by reducing them into their basic form, known as stem. It helps to make related words appear the same by remove prefix or suffix. Stemming is beneficial in tasks like analyzing text or comparing words because it treats similar words as if they were the same word, and it helps to standardize them and to make it easier to analyze. And the code demonstrate three stemmers. They are Water, Lancaster, and Snowball. And each stemmer takes a word and return its stem, which is the base form here. And the stemmers use language-specific rules and patterns to find the common form of the word. This this is the patterns. And lemmatization uh, aims to simplify words by reducing them to their basic form, known as lemma. And it helps to ensure that words with different forms are treated as the same word. And in the code provided here, the word NAT lemmatizer from NLTK is used for the lemmatization. It demonstrates two types of lemmatizers, one for nouns and the other for verbs. And each lemmatizer takes a word and finds its lemma based on whether it is a noun or a verb. This one is noun and this verb. This is the algorithm. Um, word chunking. I'm sorry about that. Word chunking breaks a long piece of text into smaller, manageable parts. Each part, are called chunk, consists of specific number of words. The purpose is to organize the text into more manageable units for processing or analysis. And code uh, achieve this by using the chunker function, which takes an input text and splits into chunks of a defined size. It goes through the words in the text, adding them to a current chunk until the desired chunk is reached. And once a chunk is complete, it will be stored in an output list. And the last chunk may have fewer words if there are enough remaining words from a complete chunk. Also, it specifically demonstrates this process on the brown corpus, which is the collection of text. It divides the corpus into chunks of specific size and then provide information about the number of chunks created. Also, it shows the first 50 characters of each chunks for better understanding and visualization. Just to bring it into chunk and show the first 50 characters here. And IDF, which stands for Term Frequency and First Document Frequency, is a method used to evaluate the importance of words in a collection of documents. TF examines how a word appears in document. The more times a word show up, the higher the TF score for the specific document. And IDF determine the rarity of word across all the document in this collection. It will show how unique or important a word is by considering the frequency throughout the entire dataset. Um, To calculate the TF-IDF score for word in particular document, you can multiply the TF score by its IDF, and the result score will reflect the significance of the word in the document and the entire collection. And the code on the hands-on demonstrate the process of using TF-IDF to train a text classification model. It involves transforming the text data into numerical representation. And this and the code in the Google Colab. Oh, the TF-IDF. Here. Yes, this one. The first we import the library and then define the category map, then get the training data set. After that, we build the count vectorizer, then create the TF-IDF transformer, define the text data here, we input, and then we train the multinomial naive Bayes. After that, we transform the data using count vectorizer, and then transform it using TF-IDF transformer. And finally, we predict the output and then print the text. In this one, the output. Okay, and number two, intelligent search engine that allow searching through image have become popular because they offer several advantages. The first is visual representation. Searching with image helps users to find information visually, which is often more effective than text. Image can describe details and concepts into more understandable way, making the search process more intuitive and user-friendly. And it's from the journal, the research of evaluating visual information retrieval system. And then the other advantage is content discovery. Image-based search engine enable users to discover new content and explore different visual sources. They can find related image, discover visually similar content, and explore diverse contexts and perspective through image. And as it's mentioned on the journal on searching for image on the web, a review of the state of the art. This is how the search engine works. And the other advantage is cross-modal search. The search engine bridges the gap between different media types, allowing users to search for image based on the text queries or vice versa. This integration of multiple modalities enhance search capabilities and help users to find relevant information from different perspectives. It's like here, it's an input of image, and then the character will be outlined, find the line and words, and then if it recognize a word, then it will be there is the output. And this is from the journal of video retrieval using speech and image context. And from all of that, intelligent search engine that allows searching for image have some disadvantage. And first is limited contextual understanding. Interpreting image and understanding their context is challenging for search engine. They usually primarily rely on visual features like object detection, which may not be captured, the full meaning, or depicted what what is depicted on the image. And contextual understanding in image-based search is still ongoing on the research area. As mentioned in ImageNet, a large-scale hierarchical image database. So it is limited, the contextual. And next disadvantage is subjectivity and ambiguity. Image can be subjective and open to interpretation. Different users may assign different meanings or descriptions to the same image, leading to ambiguity in search results. And results resolving this subjectivity and providing more accurate and personalized image are still a challenge. And it is mentioned on the content-based image retrieval with relevance feedback in MARS. This is the block diagram of content-based image retrieval system. And the next disadvantage is lack of metadata. Image often lack explicit metadata or descriptive information, unlike text-based content, of course. And this makes more difficult to categorize, to filter, or rank image search result more accurate. Developing effective method for automatic metadata still mm, ongoing on research focus, and it is mentioned on visual information retrieval using image with near duplicate semantics. And in this picture, we see the visual similar image and the exact duplicate, which is the same image, and the other is a full duplicate, and this one is near duplicate because it doesn't entirely the same. Like it says in the dog, it has different colors. And for number three, query dependent ranking models for educational search engine have specific purpose. It is to make the search result more accurate and relevant for educational queries. In the educational search, people tend to look for specific information related to their learning or research. The queries can be different based on the course they're studying and their grade level. A single general ranking model may not be able to handle specific needs of different educational queries. And to address this, query dependent ranking models are used. These models take into account the actual query words and information about the people who submit the queries. They create specialized ranking models based on two important factors. The first is the course of the query, and the second is the grade level of the person making the query. So basically, the educational or the grade level. And by creating separate ranking models for different grade levels, the search engine may provide more accurate result compared to using just one general model. And these models are customized to match the needs and characteristic of each grade level, considering the educational context. And in educational search, ranking models are customized based on specific characteristics of the queries to provide better search results. And this is the explanation. The first is query variation. Educational queries can be different in popularity, length, and what information is needed. Using a single ranking model for all queries may, of course, not be giving good result because of the diversity. The second is customizing the model. Researchers have tried different methods to handle query variation. First way is to find the most relevant training example for a query by looking at similar queries. And this helps create a ranking model specifically designed for that query. The third is separating the models for different topics. Another approach is to train and spread ranking models for different topics related to educational queries. For example, one model for math queries and another is for science queries. Of course, it's different. The result for these models are combined to get the final ranking for a specific query. And the fourth is models for specific intent. Researchers have also built models for specific query intents. They create a ranking model for each training query and then can group the similar models together. And finally, a model is trained for each group of queries with similar intent. And the last is considering query specific features. In educational search, features like the course and the grade of query and how often it's searched are important. Of course, The ranking models take these features into account to improve the accuracy and relevance of the search result. And here is the process. We got the document and indexing and return the relevant document. The number four uh, is yes, meta search optimize the process of meta suggestion. Meta search, as mentioned in the article for this number, is a technique where the initial query is sent to multiple search engines and the search results from these engines are combined to provide more comprehensive and diverse information. In this article, it is mentioned that traditional query suggestion based on user logs are not suitable for small search engine without logs or for queries not included in the log. To address this, the article introduced meta suggestion, um, which are new way to extend query suggestion without relying on the user logs. Meta suggestion gather candidate queries from different search engine. This is different search engine. Um, Similar how to meta search combine the search result from multiple engine. This is the meta search different with different search engine. Um, this approach helps to overcome the limitation or traditional suggestion by providing wider range of suggestion from various sources. And this is particularly useful, of course, for small search engine without enough user data or for queries that may not be well represented in the current logs. And B is the process of meta suggestion involves combining suggestion from different search engines to give user a wider variety of helpful suggestion. Here's why. The first is initial query. First, when a user search into using a search engine, the meta suggestion engine will receive their initial query. After that, the candidate queries. The method suggestion engine gathers the suggestion from various search engines known as the target engines. The suggestion become the candidate queries for the meta suggestion engine. The third is aggregation. The meta suggestion engine combines the candidate queries based on the type of the user initial query. Just like this, the example. If the user query is English, the engine collects suggestion from English search engine like Google. And if it's in Korean, suggestion from Korean search engine like Naver are included. The fourth is re-ranking. Since there can be many candidate queries, the meta suggestion engine ranks them into using an algorithm. This ranking process evaluates and organizes the suggestion based on factors like relevance and usefulness. The goal is to show the most helpful suggestion first. And the last is query suggestion. Last, the meta suggestion engine shows the top ranked suggestion to the user. The number of suggestions displayed might be limited to fit the screen. And this one is the search engine without query suggestion. This one is the search engine with query suggestion. Okay. Um, C is precision measures how accurate the suggested queries are. It looks the proportion of helpful and relevant suggestion out of all the suggestions given by the MSA, while recall measures the completeness of the suggested queries. It calculates the proportion of relevant suggestion that the MSA successfully retrieve out of the relevant suggestion that can be provided. So, in simple terms, recall tells how well the MSA can find and present a wide range of relevant suggestions to the user. For the MSA, the precision is important to ensure that the suggestions shown are accurate and relevant. This prevents user from being overwhelmed with suggestions that are not useful. And when the MSA has high precision, it will increase user satisfaction by providing more helpful suggestions. And similarly, recall is important to ensure that MSA doesn't miss out on valuable suggestion. It aims to cover a broad range of relevant suggestions, giving users a comprehensive set of options to choose from. When the MSA has high recall, it means it is effective in capturing diverse range of potentially helpful suggestions. And considering both precision and recall allows us to evaluate how well the MSA perform in terms of the quality and coverage of the query suggestion. Striking a balance between precision and recall is crucial to deliver an accurate and comprehensive suggestion to users. To also, of course, to improve their search experience. Um, we've let evaluate traditional relevance based NDCG and the new actual predictive hit based precision compared to Google query suggestion. MSE showed a 17% performance improvement in NDCG and 31% performance improvement in precision. Like this. This is the comparison between the MSE to Google, Naver, Down, Yahoo, and Bing. This is the recall and the precision. And this is the NDCG. Okay, that is. I think that concludes my presentation on the final exam. Thank you very much, Miss. Good evening.